lot of you techs know about this already. It's called a two-stage temp sensor. Let's go ahead and go to the next slide. And there it is. There's a chart, not necessarily with resistance, but with the temperature now. So the voltage, which is commensurate to the resistance change, a different resistance, a different voltage drop. The voltage goes from about 5 volts down to about 1 volt at around 89 degrees, about 90 degrees, 100 degrees, somewhere in there, Fahrenheit. We make a shift on this particular chart. This is a typical GM two-step temperature sensor arrangement. So we keep progressively going down, and we're getting ready to get to the point where it's hard to tell the difference between 9/10 of a volt and 7/10 of a volt and so forth. So for more resolution, for more accuracy in the computer, they make this shift. So now we actually change the whole ball game, if you will, go back up to about 3.5 volts, and then as we progressively get warmer from here, we go down again. The reason for this, we don't have a difference in resistances. It's progressive, 177 ohms, progressively up to 100,000 ohms. And as the temperature, 212 down to -40, we actually change that pull-up resistor. If you remember that pull-up resistor inside the ECM, we'll show you again, that pull-up resistor is changed when you get to a certain temperature under the hood. When this voltage gets to a certain point, which is related to that temperature, a circuit changes this resistance inside the computer. How does that affect you? This is a little sidebar here, and it'll end up as a tech tip, I'm sure, one of these days on the AVI website. It affects you because if you're not blindly sticking parts on the car whenever a check engine light comes on and says something to do with a coolant sensor. Let's say maybe you did do that initially, coolant sensor code, and you threw a new coolant sensor in it. But that didn't fix it. So now you get the meter out, you get your scan tool out, and you start reading PIDs and maybe back probing for voltage right here, like we saw earlier with the meter reading the sensor itself. So you leave the key on, you plug in the meter here and here, or out under the hood where it's easy, here and here, and you're looking at voltage, and you see this going on with your voltage. Voltage dropping as the engine warms up, dropping, all of a sudden, bang, it goes up momentarily and then starts to drop again as the engine warms up further. You think something's going on here. That's normal. What's going on, I will show you in this next picture, is if we can look inside the dotted line here, that's inside the computer. There's the pull-up resistor, all right, and there's our 5 volts at the top of the page here. Here's our ground from the coolant sensor. This would be under the hood in the water jacket, the coolant sensor. That's that thermistor, changes resistance with temperature. And there's the 5 volts going into it. But the inside story here that will help you understand why this happens on a car is our 5 volts goes through 2 resistors normally. There's the first one, and it says R1, resistor 1, 3.65 K. That's 3,650 ohms. And then R2, they're both in series, so they act as one. R2 is 348 ohms. So the two together, I'll just round the numbers off and add them together in my head, about 4,000 ohms with the two together. So if this resistor was about 4,000 ohms at a particular temperature, they'd be equal, wouldn't they? And they'd both drop 2.5 volts. The computer would see 2.5 volts here. You would see 2.5 volts out here with either your meter or the scan tool. But what happens when we get to that shift point, around 100 degrees or so, as we saw earlier in this chart, what happens when we get to this point of temperature right here is that resistance goes down and the voltage drop goes down under the hood. We have this transistor turn on. And when a transistor turns on, a little bit of current goes into this part called the base, and that acts as a floodgate, if you will, to allow lots of current to go through this path, the blue path right here, the collector to emitter. So this basically acts like a little toggle switch. And so when this transistor turns on, we no longer have a path going this way. The electrons say, forget going through this 3,500 ohm resistor. I'm going to go through the transistor. It's on now. And then I'm going to go find my path to the sensor through a 348 ohm resistor. So the electrons take the path of least resistance like you've learned years and years ago. So now, instead of going through 2 resistors, I go through 1, and what's that going to cause? Less voltage drop and we're going to go back up here to 3.5 volts and taper back. That's for better accuracy, but that's something you as a tech had better know when you're getting deeper into diagnosis using a meter or even a scope over a long time base to watch your coolant sensor analog signal. Now, for you advanced techs, maybe you're brushing up on your A8 so you can do a recert. Let me give you something even deeper, just briefly here. On some very new cars, and this is a trend for the auto electronics business with computers, make them smarter and make them smaller. We have a two-step, like we just seen, 2 steps. I can either go through both resistors when the transistor is off, and that's 4,000 ohms versus whatever we have here, voltage divider network, or we can turn the transistor on when it gets warm, kind of like shifting gears to get the higher gear, shifting this resistor out. Now we go through the transistor and only through this resistor, and that gives you a little different variation resolution on your voltage. Now, we just talked about that. Let's go into the world of Kia and Hyundai and see what they're doing. Now we have the same circuit here, it's just multiplied times 2 because we have not only a coolant sensor, we also have a sensor for transmission fluid. Well, if you think about it now, antifreeze, transmission fluid, they go hand in hand because typically automatic transmission, where do you cool the transmission fluid? In the radiator. So typically they're the same temperature, but we'll have different sensors for both of those fluids. And we have transistors to turn on and off. The extra resistor, just go through 2 of them or just go through 1 of them and then out to the sensor. Same thing down here, temp sensor number 2. Go through both resistors inside the computer or just go through the 1 resistor, the smaller one, when it warms up for better resolution. So we're doing that, basically 2 of these circuits, 1 for the coolant sensor, 1 for the transmission fluid. Everybody good so far? It's just normal stuff that we just taught. However, look what controls the base of the transistors. You might think of the base current like a toggle switch handle on a toggle switch. When this little bit of 0.5 volt or so goes into this transistor, transistor turns on. What's controlling it? Both of these transistors controlled by the same output from a microprocessor. That means when one turns on, the other turns on. Well, that's fine and dandy if both of those fluids, the engine coolant and the transmission fluid, are at the same temperature. But what if your transmission's hot and your coolant's a little cooler? That happens, and vice versa. Your coolant's hot, you're overheating the radiator perhaps, but your transmission's not doing much. You're sitting still in park or you're cruising around nice and easy, going downhill. That's when we have to do something a little different, and here's a chart that shows you what's going on. And we have a little chart, you can look at this in your manual, but basically when the coolant temperature and the transmission temperature are pretty close to the same, the transistor is completely off, or when it's warm, but they're still both warm, the transistor is on, it stays on for both of these 2-step resistor circuits. It's when they get a little bit out of phase with each other. Transmission's a little warmer, coolant's a little hotter, or vice versa. That's when the computer pulses this base current to both these transistors on and off rapidly. And when it's on for one, it reads the coolant, and off for the other, it reads the transmission fluid. How does that affect you? If you were to hook a meter up to either one of those thermistors and just warm the engine up because you're looking for a phantom coolant sensor code or transmission fluid temperature code, whatever, and you get to that certain point where these 2 fluids are out of line with each other temperature-wise, and we get this on-off, can you imagine what a meter's going to show when it's rapidly turning off and on? It's going to kind of rattle around and act like it's going crazy, and you're going to think you've got a crazy computer. In reality, it's working as designed, and you won't find that in any service manual. You'll find a little bit of a trace of it in the Kia or Hyundai training manuals, which, by the way, are free if you go to the NASTF, National Automotive Safety Service Task Force.org, and look at the OEM matrix and go right to Kia or Hyundai and look up the new model features for some of their vehicles. You'll find this written up. But this is a little mind bender for those of you who use a meter a little bit more thoroughly and do diagnostics on the analog circuit like a coolant or transmission fluid temp sensor.